Okay, we're going to continue talking about Unit 10, Properties of Circles. Understand that what we're about to do, these are your notes for this section of this unit. So you are responsible for filling this out as I'm filling it out, just like you would for regular notes. So these are what the notes look like that you should already have out. Unit 10. We filled this out last time, so if you were absent, you'll need to get that from somebody. You need to flip over a couple of pages. We did this. We did arc measurement and properties of chords last time. And then these rules with chords and diameters that are perpendicular to chords. We're going to flip all the way over and do the section on inscribed angles and polygons in this part of the unit. First thing is to define what an inscribed angle is. We've talked about central angles, which a central angle is an angle that has vertex is at the center of the circle. A central angle would look like this. So we have a circle, vertex at the center of a circle. This is your central angle. What we've done with inscribed angles is we've moved the center from the circle, from the vertex from the center to the edge of the circle, which puts it on the circle. That is what an inscribed circle would, or inscribed angle would be. An angle whose vertex is on the circle and has chords as sides. We're going to name this A, this point B, and this point C. The angle would be named angle ABC, and it is an inscribed angle. The intercepted arc of an inscribed angle is very similar to the intercepted arc of a central angle. It is the arc that is contained within the angle. So it lies in the interior of the angle. So this is the intercepted arc, arc AC. So AC is the intercepted arc of angle ABC. If you have a hard time seeing that, sometimes you can trace the angle. If you start at the vertex, you can trace it and see where it intersects the circle. And the between those 2 points would be your intercepted arc. The measure of the inscribed angle, this is very important. The measure of the inscribed angle is 1/2 the measure of its intercepted arc. When we dealt with central angles, like C is a central angle, the central angle is exactly the same as the measure of its arc. So if angle C is 100 degrees, then AB is 100 degrees as well. The inscribed angle, angle D, would be half that. So angle D would be 50 degrees. I'm going to write down that angle C, the measure of angle C is 100 degrees. Angle C is a central angle. But that's what we talked about last time. AB is the intercepted arc of C, which is also 100 degrees. And then going backwards to the inscribed angle, angle D, the measure would be 1/2 the 100 degrees, which is 50 degrees. Over here I'm going to write the measure of angle D is 1/2 arc AB. Again, the inscribed angle is half of the measurement of its intercepted arc. Just to look at a few examples of what this would look like, because sometimes when you work examples, it makes it a little bit easier to see what we're talking about. Here is an inscribed angle in this circle, C. If I was to tell you that the measurement of this angle is, let's say, 40 degrees, the measure of its related arc, or the intercepted arc, would be double that, 80 degrees, because 40 is half of 80. If I was to look at this and tell on the next side angle, you have another inscribed angle. This is circle C. Notice it doesn't go through the center this time, but that doesn't matter. It's still an inscribed angle because the vertex is on the circle. If I was to tell you on this one that this arc measurement is 160 degrees. Well, the inscribed angle is half of that, which is 80 degrees. And then on the last example, we have another inscribed angle right here. It doesn't have a name because there's no, we haven't named it with any letters. If I was to tell you that this angle was 45 degrees, the intercepted arc of that angle would be 90 degrees. Okay. A couple of examples that we will work with this. If you look at example 1, example 1 has the angle measure SRQ given to us. That box, we should be familiar with that box. It means it's 90 degrees. So the measure of angle SRQ is 90 degrees. That's the given information. I messed up right there. That's the given information. The intersected arc of this angle, if I trace it out, here is where the one side of the angle intersects the circle. Here's where the other side of the angle intersects the circle. So between those 2 points is your intercepted arc. The intercepted arc of this 90-degree angle is arc QTS. They are related because arc QTS is going to be double what this 90-degree angle is. So I have this as 90 degrees. QTS would be 180 degrees. Now I'm going to ask you to pause the video and do parts B and C on your own to see if you can figure out what those measures would be. All right, now that you've done these on your own, I hope you actually paused the video and did that. You should have gotten that this arc XWZ was twice the measurement of this angle, which is 230 degrees. On part C, you should have gotten that this angle, now notice you were given the arc, so you're looking for the angle. The measure of angle NMP is half the measurement of this arc, which is 50 degrees. If you did not get those, then rewind the video a little bit and figure out where you messed up. On part D, you're asked to find the measure of angle BAC. So I'm going to trace that angle from B to A to C. This is the angle that I'm looking for, this angle right here. I'm given the central angle, which is this angle BOC, which is 130 degrees. The central angle is the same as its intercepted arc, which is this arc BC. So that would be 132 degrees. Now, to go back to the inscribed angle is half of that arc. So the inscribed angle is going to be 132 degrees divided by 2, which is 66 degrees. So the measure of angle BAC is 66 degrees. Again, we know that the central angle and the arc are exactly the same, and then the inscribed angle is 1/2 the measurement of the central angle, of the intercepted arc, not the central angle. On part E, we are asked to find the angle BAC. That is this angle right here, BAC. Well, when I look at this angle, when I continue tracing it out, you can see I continued tracing it out over here. The intercepted arc of this angle is between B and C, this part right here. Arc BC. I don't have any angle relationship to that arc. This angle was not given, but the one right next to it is given. That angle is supplementary to this angle because you have a straight line. You could also look at the whole circle, that 94 and 94 would be vertical. These two would be vertical, which would mean you would subtract them from 360 and divide by 2. Either way, if I do 180 minus 94, because again these two are supplementary, I get 86 degrees. If I did 360 minus 94 and divide it by 2, you would still get 86 degrees. That gives me the measurement of that arc, because that is the central angle that is opposite this arc. This angle and arc go together because 86, the intercepted arc of this central angle, is that arc BC. Now that will help me find this inscribed angle, because the inscribed angle is half of that measure. So the measure of angle BAC is 1/2 of this 86 degrees. So that would be 43 degrees. Again, look at that and make sure that you understand what we were doing with that angle measure and how I worked that arc and angle together. Again, you can see that the intercepted arc is BC of the angle BAC, and then the central angle that goes with it is the one across from it, which is 86 degrees. Okay. All right, the next rule that we're going to talk about is one about inscribed angles and how when they intercept at the same arc. This picture is a little bit confusing when you read what is here, so just listen carefully and pause the video if you need to, because we're going to look at what happens when two inscribed angles, that would be angle A and angle B, intersect the same arc. So if I look at angle A, if I trace it on out, the arc that it intercepts is this arc CD. Okay, if I look at angle B and I trace it on out, the arc that it intercepts is also CD. So they have the same intercepted arc in common. And what that means is that these two angles are going to be congruent. Think about that both of them are half the measure of this arc. And if they're both half the same thing, then they are going to be equal to each other. It's like if you're taking half of 100 and half of 100, they're both 50 degrees, if that was the number. But they're both taking both half of the same number, which means that they are both congruent to each other. So I'm going to put that angle A and angle B both intercept arc CD. We can see that with the picture. They both meet at these 2 points, C and D, and they both open up to that arc. That means that angle A is congruent to angle B. They are the same measure. Okay. With example 2, you are given that the measure of angle E is 75 degrees. Well, if I look at angle E is this angle right here. I'm starting at E, going to trace it on out from both sides. I can see that its intercepted arc is this GH right here. That's the intercepted arc of angle E. I'm supposed to find angle F. Well, I'm going to start at angle F and trace it out to see where the intercepted arc is. And the intercepted arc is the same as angle E. That means that angle E is congruent to angle F, which means that the measure of angle F is 75 degrees. All right, on the next problem, I have two equations, one for this angle and one for this angle. And I've got to see if they intercept the same arc. If they do, I can set them equal to each other. So I'm going to start at the vertex and trace it out. And the intercepted arc is between those two pieces that I just traced right here. The other one, I'm going to start at the vertex and trace it. And the two intercepted pieces, or the intercepted arc, is the same arc. They both intercept this arc right here. So I'm going to set these two expressions equal to each other. 2x plus 1 equals 4x minus 3, and solve this. I would start by subtracting 2x from both sides. You get 1 equals, it's 2x plus 11. 11 equals 2x minus 3. Add 3 to both sides. You get 2x equals 14. Divide by 2. And x equals 7. You have another video to finish this set of notes, so please continue watching.